If you look at this, then it's going to be just a first parameter here, then comma, then a big mess here, or this one, up to this point. So in the end, only really two parameters. So you have this integral constant, and then you are in trouble because template ref. Can you, instead of figuring out, yes, the name, what is the content you have here, maybe from the template ref, we could get the corresponding template, the class template itself. And from there, we could read what are the number of template parameters. That would definitely be a better idea, I think. It's just then to figure out what are the actual parameters that we use for the instantiation. Yeah, we might still get this big mess. Or we could do something like that's really something I don't want to do. But let me just consider that we have a template ref, right? So can we just use that then? If it's nil, then we really have something like that. If we get to this point, so here we really expect to find a template as child. Cursor. Okay. How do we handle this template ref? I think we must have a mechanism to handle that already completely. Okay. So we just need to get this template ref, and then we could ask Luna to provide us with a class template then. That may work. Get class template here. It's going to create a template or from a declaration cursor. So Luna, my cursor here. Not really. You'll rather need register class template. And even that, it's not really creating the template. So where do you create that? When you do the parsing, if you don't go there, you don't do the parsing. do we have something like registering class template? Because we do the parsing of it. Let me see, where do we have all this mess? Resolve, registering class template. Okay, so 2055. Let's go both. And we're searching for STD. Oh no, we just need the name of it. That would be in really. No, it's not quite registering that automatically. I need to force the parsing on this location, I think. So let me try to think a bit about it, and then I'll get back to you when I have some additional explanation to provide. Okay, so I'm refactoring what I was doing here concerning the retrieval of the arguments and the assignment of the template parameters. What I think is the correct way to do it now is this. When we have this base cursor, so basically we are here, we're going to find the first template reference. So that's going to give us this template reference. In fact, from this name already, I could probably just retrieve the list of template arguments. But I could go through with that and perform the actual parsing of this cursor. So this is what I'm trying to do here. I retrieve the template ref, and I really expect to have a valid ref at this point. This is done only when we don't have template class registered with this full name. So you would just retrieve the corresponding reference cursor. So that's the actual template, class template cursor. And I was thinking that I would be creating an empty shell of cursor and then call what the function is, register template ref, I believe. Class template, yes, because you need the actual cursor and the template class. But in fact, no, that's not what we need to do. But what we need to do this properly is rather to ask the C-long parser to perform the parsing of this cursor that we have. Except that to do that, we need a parent scope, and the parent scope is not really the class itself. It's a parent namespace or whatever. So we should really rather try to get the parent namespace here. We already have in the template name that we have extracted from here, we don't have any template parameter part. So this part is normally fully discarded, even if it's maybe not correct. It should be discarded. So we only have here, for instance, std integral constant. So if we just split this on the column, then we should get the list of namespaces. So that's all we really need. I'm just wondering, could we maybe make this a utility function or something like that? I guess maybe just in Luna. Let's make an additional function here. get base, get parent namespace. So you would provide, for instance, a class name. And then in the details, vector details, utils. Vector list, whatever. So you would provide that's not a string, it's actually a namespace. If it's a class, is a class a namespace? Not quite. I mean, this is something is a bit weird. Maybe I should make that a bit different. A class should really be a namespace. Basically, a namespace is just a scope. There was no real reason to introduce a namespace concept except giving this a name, I guess. I don't know. We'll see if this is conflicting with anything or not. Because, for instance, if this happened to be a real class, then we'll be in trouble because we're going to get or create namespaces here. Anyway, let's try to get the parts. So local names, and you're going to do putils split. So you split the class name on those colon symbols. We really expect that we don't have any template parameter thing here. So check CL name, find this. We expect this to be a nil. All right, once we have that, actually we should remove the last name, because this is actually the target class name. And then you start from the root namespace. And for each name, you simply do namespace equal namespace get or create namespace with that name. And eventually you will have to return that namespace. Okay, get parent namespace. So we can use that now for every kind of string. So we have the template cursor that we want to pass. Then we can retrieve the namespace by doing Luna get parent namespace from the TPL name. Oops. And once we have that, I think we can do tbl. I guess that is what we will get as a result. And we request the parsing. Parse class template. We need the cursor, so tbl cursor. Oh no, self semicolon. No, semicolon. What did I say? Column. So class cursor, and then the parent scope, which is the namespace ns. The class name, I guess we don't need to provide that. It's going to be figured out automatically. Is this really returning the class template object? So we're returning a result of parse class, and parse class is going to prepare a scope, blah blah blah, as template. So you prepare a scope, you do the full parsing, and you eventually return that scope, apparently pushing this, parsing the content as needed, blah 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 blah, and returning this indeed. So we should be good with this, and actually we are already in this part. So so we get the template, and this should actually add the appropriate number of template parameters. And then we have this additional concern concerning the arguments that we should use here. Because we have cases, if you remember, like not in the ALST, but in the bind Qt. That's quite interesting. If we have this kind of stuff, we definitely don't want to proceed. And also, if we have, these are simple type names, these are okay. Here, for instance, that means something went wrong. We could not pass those template parameters properly. So we need to do something special in the function we have, resolve template class and argument. This one, it's in Luna manager. We come here. So what we are doing here is we find a name where we have those templates, and if well, we have the first ID, okay, and then find. That's not good. I mean, that should really be the last element of your name. Oh no, because in the general case, you could have, for instance, pointer on the template. But there should really only be one of those characters. So maybe I could have a function like counting the number of symbols like that, template symbols. Let me see how to provide that. Okay, let's go. I guess we could put that in the util package here. So we should go in base util, and we'll add another function that would be, I guess, at the end. Util count count child str and ch. I think all we need there is simply to start from a count of 0. To the length of the string, we'll do something like if it's the same thing as sharp, then we increment the count. And eventually we just return that count value. Alright, so we have this count char function we can use now in the Luna manager. Where is this function again? It's here. So if we find out the system we have here is just going to find the first one, which is closing. If we have multiple of them, then it's going to produce garbage. So we really want to assume that there is not multiple of them. So we should check the count first. So in the name, we count this. If count is bigger than if count is 1 already, then we can proceed with extracting the ID, getting the arguments, and then splitting those arguments and eventually returning the template class name with the arguments. If it's not 1, then we are in a tricky situation. So can we find reverse or something like that? Let me see. Okay, it's not clear to me how we would do reverse. Fine. So what we should do is what? I guess we could implement that anyway. It's a string function, so we need some kind of extension for string, and we have that in I guess it's directly in utils again. Yes, we have string things here. So we would have something like find last. And we are provided a pattern to do that. I think when we do find, we actually get back do we have access to find here? Not sure. So Lua string find. Yes, it's returning both indices. Is it returning? What is it returning if it's not finding anything? Come on. or nil. Okay, should return nil. So we have the start and indices at least. So we can use that, and we will do something like local ID1 or IDX1, IDX2, and that would be string find pattern. So this gives us the initial location where we find this pattern. Why are you complaining here? Duplicate field? What do you mean duplicate field? Okay. So we have that, except we're not using two. That's the start which is given then, and the second argument. Come on, can I have a proper definition, please? Oh, finally. So we have the pattern, the init, and the plain text. Init. Return the indices of x1, start and end. Otherwise, return nil. A third optional arguments. Where to start? Default to 1. It can be negative. Okay. Value of 2 and 4 argument is a plain text. Okay, so we can provide the init location. Good. Which means that actually we should also get here the start index and the end index. And where do I have the first definition? Here we can remove this. Am I using this somewhere already? I doubt it. Oh, we are. Find last. But only for simple characters, so it's not applying any kind of regular expression here, so that's why it's just usually working. But otherwise, if you have a regular expression, that is more, in fact, pattern. You also want to get the final index here to say where you want to start. So if the start index is not nil, the proper index, you need this one, and you also need the proper end index, I guess. So if it's not nil, you would store this, and the end index should be what you have in IDX2. And when you're done, you should return p index and p idx2, and then you continue searching. You search, and you also need idx2, and you find starting from, in fact, idx2 plus 1. In case we have a single character, the start index should be the same as the end index anyway. So you start from the next character here, and you search again. And while it's not nil, you keep the latest one. And at some point you will not find anything, so you will just return the last instance you found. Great, which means that when we use this now, I guess that should still work. Retrieving the first element on the stack and discarding the other one. Same thing here. And so now we could do here find last. I think. Find last, and in fact, you could do that outside of the loop. And you could also get the arguments outside of the loop. And in fact, the template name also, you need to get this outside of the loop. Then count. If count is bigger than 1, it means that we have something in those arguments that is not possible. So we could just display a warning message here. And in this case, you just return the template class name and nil, because you would say, okay, I cannot figure out how to pass that. All right, and this is it. Now, back in the ceiling parser, what do we have? Here we may just retrieve nil in this case. And if we have nil, we should really check that also. Else, if then in this case, you would say just ignoring complex base template class. That would be, I guess, the full name again. Oops, no, sorry. And this is it. Right. So let's see where we go with this. Don't need to write the AST. Tried. CNAME, nil value. Where exactly is this happening? 859. Okay, you expect me to provide a class name then? Really? You could retrieve this somewhere. From the cursor. Just the cursor should have its name already. Come on. ALC, let's see. What is that? I think that's cursor spelling. I'm not sure about it. Let's see. Oh, that's going to be in cursor rather when we write the AST. I think that's the one. Cursor kind, then in double quotation we have the CNAME, which is a spelling. So we get the cursor spelling. That's definitely going to be the name of it. So this or cursor spelling, get spelling. Yeah, that was the spelling. We could also just retrieve that from the cursor when we call the function. Sure. Never mind, that should be okay. So let's try that again. Next error, next up. Mismatch a number of instantiate parameter indices list. We don't provide anything. Whoa. Oh yeah. Oh, that's another very cool thing. If we have those 3 points, that's an error for us. So we should go back into the Luna parser, and when we have to do this, we have the list of arguments here, and if we find yeah, we could do that just here. If count is equal 1 and args find this equal nil. But to find this, we need to escape those characters. So in this case, we proceed with those arguments. Otherwise, we should really ignore this. Still not quite there. What? Wait. Parsing class template. This one. So it doesn't come from where we are executing this code. Okay, let me think about this. So yeah, with this issue concerning the indices list, we already have a problem where we have this message. Base type is this, and this is occurring here. In fact, we get the base type as a name in this case, and we just start with a cursor, we get a canonical type from it, and then we pass this name to get a name, and then we go with string processing to actually build a templated type from this name, which I believe is a bit crazy because this is making us lose track of some information. And in fact, we have this auto replacing generating template parameter name, blah blah blah, renaming this indices list to this thing that doesn't make sense at all. So I think we need to be a bit more clear about that. So again, let's try to get the AST. Yeah, and it's failing in here, but the AST should be up to date. Actually, we don't really need to regenerate that. It's not going to change, I believe. So what about those indices list? Let's go at the very top of the file and search for indices list. So this is where we will start getting this class template. Indices list int. What is this int actually? Doesn't sound like this type ref, you're referencing this type. Wow, okay, that's getting tricky. So this is in a class already. It's in the namespace Qt private. Okay. But how comes we don't have a class template? Indices list, where could this be from? Let me search for that. Not really obvious. So do we have that maybe available easily in the sources for Qt? So I need to go into NervPro libraries. I guess this one would work also, and include probably Qt core. So find in this folder this thing. So template with oh my, how am I going to handle that? This will not work. Okay, let me think again a bit more. Hey, so resuming the recording concerning this devlog session. When I was stopping last time, I was on the issue with the indices list parsing. So this was not working because of those